All right, let's look at one more example of net change here. Um, there's no snow in Janet's driveway when the snow begins to fall at midnight. Okay, so no snow at midnight. From midnight to 9, snow accumulates on the driveway at a rate modeled by blah, blah, blah. Where T is measured in hours since midnight. Janet starts removing snow at 6 a.m., so she gets up and starts shoveling snow at 6. The rate G of T at which Janet removes snow from the driveway is modeled by this. So 125 cubic feet per hour to start with for the first hour. Second 2 hours, she goes a little bit slower. Makes sense, she got a little tired. So let's start with the questions here. How many cubic feet of snow have accumulated in the driveway by 6 a.m.? So before she starts shoveling, how much snow is there? Well, that's the rate of change of the snow, which is F of T. So from 0 to 6, midnight to 6 a.m., F of T, which is this expression up here, we're going to integrate that from 0 to 6, and we get 142.275 cubic feet. B, find the rate of change of the volume of snow in the driveway at 8 a.m. Okay, well, that's going to be the snowing rate of change minus the shoveling rate of change. So in other words, F of 8 minus G of 8. So 7 times 8 e to the cosine of 8 minus 108 gives us negative 59.583 cubic feet per hour. So she's making a dent and removing more snow than is coming down. So she's getting her driveway clear. C. Let h of t, so this is a new function, represent the total amount of snow in cubic feet that Janet has removed from the driveway. So this is her rate, and now we want the total expressed as piecewise. So h of t equals, so it starts off easy. The total is 0 until 6 a.m. Okay. Then from 6 to 7, here's our net change. So we start at 0 and we add the rate of change from 0 to time t. So whether that's 6:15, 6:30, 6:45, from 125, that's the rate of change from our function g dt. So integrate this real quick, evaluate that, and we get 125 times t minus 6. Well then, from 7 to 8, we have some starting value plus 7, not 8, 9, sorry. 7 to 9 of she was shoveling slower, 108. T minus, or not T minus 7, x dx. The starting value is going to be at 7 o'clock. Well, at 7 o'clock, she had removed 125. 7 minus 6 is 1. 125 times 1 is 125. So we have 125 plus 108 times t minus 7. And that's from 7 to 9. So let's see. D. How many cubic feet are on the driveway at 9? Well, we want to do how much snow fell. So the integral from 0 to 9 of f of t dt minus how much was removed. And that will be h of 9. Not an integral because this is not a rate of change. It's just how much snow was removed. Okay, so we would do that. So this comes out to be 367.335 minus, plugging in 9, we'd get, let's just do the math. 125 plus 108 times 2. So 367.335 minus 125 plus 216. So 365.335. Sorry, I should have had this done for you. Add 1. So 41. 341. So subtracting, we'd be left with 335.62 cubic feet of snow. So she's almost done. Just a little bit longer and she'll finish it out.